There are many actions, criteria, tools for evaluating the validity of information. We'll begin first with some actions. In other words, what is really to validate or evaluate information or evaluate the validity of information? And I have some verbs here that I think address this. There could be others, and you can add your own here as well. So the first one is question. And question, I think, is an important one because it is a kind of a first one or beginning. To understand the validity of something, of some piece of information, we need to question, we need to be a little bit skeptical. We need to want to at least inquire onto it. We need to investigate. So investigate refers to some kind of deep research or deep look into it. And there's the word research. So to search for it, to research, search again, right? To verify, to look over, to examine, to explore. So there are many other kind of words: to study, to spend time onto it. And also all of these all of these verbs here, which are kind of, all of these are truth seeking or information seeking approaches or actions. They involve all sorts of sub actions like read, write, converse, argue, watch, listen, think, reflect, calculate. So there's all kinds of things going on when we're evaluating information, when we're trying to see if something's true or false. And one of the big ones is read. And the reason read is actually on the top here, and perhaps the major one, because so much information and detailed information is expressed in writing, in, as we just observed, in language, in linguistic statements. So this is why reading is actually important for knowing if some pieces of information are false or true, or what is true and false, and what is valid or not. Sometimes we need to write to learn as well, because that helps us think about things, and or conversing and arguing and debating and talking. So watching could be necessary as well. If information comes in the video format, then we need to watch the video to know what it shows. So sometimes we do need to watch the thing if it is shown in some kind of video or graphic imagery. But once again, we're also probably going to need to read and so on, and think and reflect. And we may also need to calculate. This is very important for all kinds of informations out there. Mathematical, more complex mathematical, and also less complex, like, for example, just counting how many people attended the ceremony, how many people are attending the business. We want to know just if there's enough people attending or not attending, so we continue the same service or provide a service. So calculate can be simple or complex as well, but these are some of the actions. Also, there are some important preconditions. So to evaluate the validity of information, to evaluate true information, one requires intellect, so thinking about things and just being able to process information. Also, I think a degree of openness, and maybe we can also kind of add here willingness to accept, we need to be open to what the truth is, to what the results are of our inquiry. There has to be some degree of skepticism. So this has to do with the questioning and essentially just not believing everything or anything you feel like. If you just believe everything or anything you feel like believing, then you're not employing skepticism. And the issue is that you may just believe, you might be susceptible to your biases. You're just going to believe whatever your biases lead you to believe, your conditions, your situations, and so on. So courage, I think, is related to that. Courage is really important. If you don't have courage to accept the truth, it's going to be hard to accept the truth. And you may just end up believing whatever your parents told you or whatever you felt like. So courage is very important. All of these are very important, and there could be others as well. I hope you can add them to the discussion. And here then finally the actual tools and criteria, or the processes, the tools, processes, and criteria to actually evaluate it. And so this is a kind of like a little bit more formalized set of actions. So there is the systematic study. And the systematic part is important too, because it's not just a study. One day you look into some web pages that have some information. Systematic studies are more ongoing, formal study where you look not just the web pages that are the first results, but the last results too, and the different source of information. There's the experimental design that some scientists may carry out in a lab. There's technical measurements. So even just like measuring the temperature, if you want to know the average temperature in your home, you need a thermometer of some kind, and you need to be systematically measuring, in the morning, in the evening, in the afternoon, and so on. So you need tools for that kind of technical measurement. Sound argument. So here again, the linguistic explanations and just the notion of argument itself, using those probabilistic logical inferences, and understanding some of the qualities of good and bad arguments that we're going to explore. And also critique. Critique is also very important, which is the debate nature of information, the kind of adversarial nature of information, or in scientific context, we call this the peer review. Right? We give our research, our information, our propositions to others, and they just look at it and critique it. They look for flaws, weaknesses, and so on. This is also called critical thinking. So it's kind of hearing the other side of the other potential explanations. And that's all. These are all, I think, part of the tools to find true information. So let's have an example here. This is a scientific experiment as example of information evaluation. As I said, there's many systematic study. I'm not going to go over all of these, talk about some of these, mostly kind of sound argument and experimental study, but all of these are often used together, actually, and important. So experiment is a procedure for making reliable and valid claims about phenomena in the world. It's usually employed to understand causal mechanisms, so not just definitional, but cause and effect. That is the impact of one thing or event or process on another. Experiments usually consist of comparison of at least two groups where one's modified slightly, and that enables us to determine if the thing that got changed is the actual, has an actual causal impact on one of the groups. Experiments need to be performed in a repeatable way and control for implicating factors and biases. Sometimes naturally, or just not naturally, but the way the experiments are conducted or constructed already control for implicating factors and biases. But the importance is also that's repeatable way, and this has to do with the systematic notion of it. If you just do one thing one day and another thing another day, how are you going to compare those? It needs for us to know if something is true, something causes another thing. We need to be able to repeat that experiment to know if it is reliable, right? So this is repeatable, also kind of almost the definition of reliable. And we said truth is a kind of reliability. So let's take a more specific here than a drug experiment example. We will suppose you want to investigate it if drug A can help lower blood cholesterol. Okay, so that's the context. Investigative drug, it's called drug A, can help lower blood cholesterol. Well, we're going to set up an experiment. The experiment is going to need a treatment group and a control group. Treatment group and control group. So the treatment group is going to receive the drug, and the control group does not. But the control group is going to need to receive a placebo. And the placebo is necessary to control for the impact that believing in having a drug has on the treatment. This is called the bias or the placebo effect. So if you don't give the one group anything, they're going to know, oh, we are the group that didn't receive anything. So they know they don't have anything. So it's even hard to control, to compare with them. And if you tell the treatment group that they are receiving the drug, then they know they're receiving the drug and the placebo effect can take place. So just that belief itself in having a treatment already impacts, and it's the outcome of the treatment. And this is so widespread in all kinds of medical studies and all kinds of medical practice, that this is essential to all kinds of medical experiments and studies. Each group should have similar kinds of people. This is to control for those so-called confounding factors, the other things that can impact cholesterol level. So for example, if one group has many people that eat well and the other has many people that smoke a lot, it is difficult to determine if the drug impacts the cholesterol or these other factors. So the two groups, the treatment group, the treatment group and the control group has to have some smokers and some people that are not smokers, and the control group has to have some smokers and people that are not smokers. They have to be kind of similar. The implementation of experiment should be blind to those who examine the results. And that is, so if a scientist knows who is receiving the drug, the natural attachment that people have to the drug or result can bias or impact the results. So if somebody's really, they really are kind of cheering on for the drug, they really want this drug to work for financial reasons or just because they really believe in the cause, then that can impact just the things that they observe and the things that they notice and the way they approach the analysis. So it's good that the studies are blind, and that's what they mean blind. That means that the scientists don't know who got what, which group is what, until the end, until the results really kind of are come up and then the information is there. Also, furthermore, we actually need more stuff. So we need some analytical approaches to measure. That's the last one, the relevant factors, and for comparing groups. So this is also necessary. We need analytical approaches to measure the factors and to compare the groups. So two things. So for example, how is blood cholesterol being measured? Are we measuring total amount of LDL or the ratio of LDL to HDL? Or are we using total cholesterol, and are we including VLDL and so on? So all of these is important for us to get a valid, true kind of result. And are we going to measure before eating or after eating? This is all part of the experimental design. If we measure after eating, if people eat a lot and so on, some people don't eat a lot, is that going to complicate it? And we need to account for all these things. Also, how different should the results from the treatment group be from the control group to determine if the drug is effective? So let's say you have the drug group, they had reduction of, they took the drug, their cholesterol was on average 150, and after the drug, the cholesterol was 145. The placebo group took the average cholesterol level was 156, and then after they took the placebo, their cholesterol level was 153. So this one has a difference of like 5, and this has a difference of 3, and then maybe X percentage difference. Is this enough difference between the two? This 5 here, 5 points, and then 3 points here. Is this enough different to say that the drug was effective? How do we know that? So we need to have measures, and there are measures, there are statistical significance tests that we don't need to get into here, but I just want to note that we need this criteria for comparing the groups. Since we brought up this idea, and just because this is so important, I wanted to talk about some issues with that validating information, and these are cognitive biases. So there are hundreds of cognitive biases that impact how we think, how we act, how we understand, and how we interpret information. Things like, you might be familiar with confirmation bias, which points to the fact that people are often looking to just believe whatever they believed before. So that's a bias. Bias is a tendency in a particular direction. Anchoring bias, loss aversion bias, hindsight bias, optimism bias, survival bias, information bias. There are all kinds of biases that impact how we think and how we determine information. In-group bias, right? So if some information comes from our in-group or the people that we like, we're more likely to believe it. But it might not necessarily be true. In fact, some might often be more false, and so on. This does get complicated, right, when we talk about things like truth and trust. So should you just believe the people that you trust? Maybe that could be good, but then what kind of, you might be impacted by certain biases, because often, or sometimes at least, the people you trust may not have the good information. Even though you trust them, doesn't mean they know, they're reliable about the one thing you're talking about. So cognitive bias is a serious uh, issue with validating information. And just the fact also that arguments are complex and information is complex, and it's difficult to think of information just as true or false, as we said before. And we can also call unreliable information bullshit, baloney, or unsound argument. Often things are determining the validity of information is based on argument. So as one people from this call university course in University of Washington say, true statements can be bullshit if they distract you from more important facts, or give you the wrong impression about an overall situation. There are different ways to think about reliable information, valid information, and also this issue of baloney or bullshit or the wrong impression and so on of a situation. I wanted to explore some of these issues and tools related to this notion of argument. So let's examine examples of unreliable arguments. And I'm getting this from the piece by Carl Sagan, The Fine Art of Baloney Detection from 1996. So there's several types of bad arguments or unreliable arguments, characteristics or types of unreliable arguments, and we're going to cover these here. And one is so-called ad hominem, which is Latin for to the man, attacking the arguer and not the argument. So for something, for example, I heard it from John Smith, therefore it must be false, because John is always lying, and I know he lies, so it must be false. Well, must be false, maybe probably false. If he always lies, everything he says is a lie, 90% of what he says is a lie, then we can say maybe probably false, but must be false is too strong. So just because somebody always lies or lies 80% of the times, maybe 20% of the time they don't lie. So maybe that one time they said the one thing, it could be the one true thing. Argument from authority. So I saw it on the TV news, so it must be true. Or the president said, so it must be true. Or the Department of Defense said it, so it must be true. NASA said it, so it must be true. Now, it does get a little bit complicated because, experts can be part of authority, and experts do have more information. Sometimes we trust them, so that issue of trust comes on. But just because of authority does not necessarily mean true. Observational selection, so also called the enumeration of favorable circumstance. So just looking at how many countries are growing their economy with high taxes. So many countries are growing with their economy with high taxes. So you're just looking at some cases that are working and then trying to make your point that way. But you got to look at all the unfavorable circumstances as well. Another one, statistics of small numbers, which is related to this observational selection, only selecting some kind of cases. Quote, they say 1 out of every 5 people is Chinese in the world. How is this possible? I know hundreds of people and none of them is Chinese. People do this all the time. Like, just because you don't know a Chinese person doesn't mean 1 out of every 5 people is Chinese in the world. It's just because your observational selection is small, your circle is small and does not include Chinese people. Excluded middle or false dichotomy, considering only the two extremes in the continuum of possibilities. Either you love your country or you hate it. So no chance for degrees. If you're not part of the solution, you're part of the problem. I also call this absolutism, false dichotomy. Short-term versus long-term, so a subset of the excluded middle. We can't afford programs to feed malnourished children. We need to urgently deal with crime on the streets. Why can we do both? Do a little bit of each and so on. We cannot address global warming since we need to invest on jobs now. Well, this is a short-term versus long-term issue, so people confuse the two. Weasel words or euphemisms, so words providing vague explanation or casting some foul action by another name. So calling torture as enhanced interrogation techniques. This is done all the time in the military context. Calling the killing of innocent people as collateral damage and so on. And of course, you see it in all kinds of contexts, business, marketing, and things like that. Circular causation or circular reasoning. So the strong reliance on a priori conclusions. You kind of just make the conclusions from the fact itself without examining the two things. Involves simplifying the causal agent or relying on unreliable premise. So because I was voted president, that must mean I'm good. well, you kind of took the result and you just assumed that you were good before, and then that's why you voted president without examining if the person was good in the beginning. I must be right and good because I won. So you won the game. Well, maybe you won because the other person was tired, or maybe you won because the some other condition that impacted, the lighting helped you in that day and it affected the other player. So just because you won doesn't mean you were the best. Things like that. So it's circular causation. This is also, you hear people talking using circular causation all the time. And a big one too, confusion of correlation and causation. So a survey shows that more college graduates are homosexual than those with lesser education. Therefore, education makes people gay. This is confusing correlation with causation. The causation is not the college. It's just something that happens together with this other factor. And this is also related to the confounding factors. This is why it's important to understand the confounding factors, the factors that happen together, so we know which one is causing which. The economy is growing and Joe Biden is the president. That means he's helping to generate a growing economy. Yes, maybe, but maybe not. Maybe the economy is growing because of other factors and not because of Joe Biden, even though they're happening at the same time. Because you wanted to be a Democrat, this then caused you to want to help the poor. This is also kind of weird circular causation or confusion of correlation and causation. So no, maybe it's because you want to help the poor, then you wanted to become a Democrat, not the other way around. And with that, I wanted to conclude with some tools for valid and reliable information. We discussed all of these tools and some of the tools and criteria and processes. And here is a summary of considerations we need to have to obtain reliable and valid information. So use multiple and diverse sources. And by that I mean books, newspapers, web pages, Fox News and New York Times. Listen to different types of people, different perspectives, and so on. Use independent sources, so sources independent to the conclusions themselves, or people don't have a clearly vested interest on it, on the outcome of the result. And these kind of two go together. Sometimes you can detach these, but the more independent, the better. Use recorded and named source. So, so anonymous sources, like it's kind of hard to validate because it's anonymous. You never know who's behind, and it could be a trickery. It could be, things about like Canon, and we never know who Canon is. And you can clearly see that it's totally anonymous, and it's recorded, but it's anonymous. So it's hard to really know who is who. Be careful with authority. Not authority can have good information, but not necessarily means the right information. Do not get personally attached to your claim. So people do this all the time. They get personally attached. They're talking about things that they feel strongly about and has to do with their sentiments and emotions. And if you say something against it, even though if it's true, they don't like it, so they don't believe it. Encourage substantive and quality debate. So this has to do too with critique, right? You need that back and forth. You need that critical inquiry, that peer review, that critique to lead to better, valid, more reliable information. And at the same, all of these also considering alternative explanations. If you don't want to consider, if you don't want to inquire, if you don't want to question, you're not going to find the truth. So I'll leave you with these. These are some of the various topics we covered, and I'll see you next time.